In this video, we're going to take a look at the square root property, and I'm going to look at it from the standpoint of just some equations to solve first, and then we'll go ahead and take a look at a couple of application problems. But I want to start out by showing you how you end up with two answers under certain conditions. For example, if you had the fact that x squared was equal to 25, it's possible that the value that was squared could have been negative 5, right? Because if I squared negative 5, x squared would be 25. Negative 5 times negative 5. Likewise, though, x could have been 5, because if I square 5, I would get 25. So it turns out when you solve a square problem where the only value, the only variable in the problem is a square, and you solve that by taking the inverse operation, you take the square root of both sides. It turns out the answer to taking the square root of 25, yes, it's 5, but it's possible that what was squared to give you the 25 was either 5 or negative 5. So the answer to a square root property problem is a plus or minus answer. So for example, down here, if we were solving this problem, it's possible the quantity when squared here could have been negative or positive to give you 5. So when you take the square root of both sides, you'll say that the answer is plus or minus the square root of 5. And we're really referring to two possible answers, either positive square root of 5 or negative square root of 5. So it could actually be two different answers. So the only other thing we need to know about solving equations that involve squares is that you first isolate the square if there's anything else around it. So in a problem like number 2, I would first divide both sides by 5, and I would get x squared is equal to 4. And if we practically thought about it, either negative 2 squared or positive 2 squared would give you 4. So when I take the square root, I'm going to get x is equal to plus or minus 2. That symbol, plus or minus, means I really have two answers like I did above. Okay, so let's just take a look, how much more complicated could it get? Well, we might end up in a situation like this one right here. So again, we have to isolate the square first, and so I could divide both sides by 3. And I'll get x plus 2, the quantity squared, is equal to 12. Then I take the square root of both sides, now that I have the square isolated, and I get x plus 2 is equal to plus or minus the square root of 12. Then what I'm going to do is I'm going to go ahead and subtract the 2, and because the 2 is being subtracted after I did the plus minus, we really want to put it in front. We don't want to have it be part of the plus minus answer. So it's going to be two answers, negative 2 plus the square root of 12, or negative 2 minus the square root of 12. Now in a Math 65 class, we haven't seen how to go ahead and actually simplify a radical. But in Math 95, we could take this one step further and factor this radical part of the answer. And we could say that we have x is equal to negative 2 plus or minus the square root of 4 times the square root of 3. And the square root of 4 is 2. And our final answer is negative 2 plus or minus 2 square roots of 3. All right, let's take a look on the other side, and we'll take a look at a couple of application problems. And one application of the square root property is solving Pythagorean theorem problems, and that has to do with a right triangle, meaning the triangle has a 90-degree angle in it. So the Pythagorean theorem says that if you take the two sides that add up to the 90-degree angle, we're going to go ahead and recognize that the relationship between these sides, the two sides that make up the 90-degree angle, and the side opposite of it, which we call the hypotenuse, is this: if you square these sides that make up the 90 and add those squares together, you will equal the square of the side opposite the 90. So from a practical standpoint, you'd have a problem like this. if you were trying to find the height of this side, if the base was 14 and the diagonal across from the 90 was, or the hypotenuse was 16, you would say that the sum of the squares of the legs, or the sides that make up the 90, would give you 14 squared plus x squared is equal to 16 squared. And you know, sometimes x will be the hypotenuse. Then I'd have x squared over here. But because in this problem, x was one of the legs, it's part of the sum. Because it's always the sum of the squares of the sides making up the 90 will equal the square opposite the 90. And then I just solved this like I did on the problems on the other side of the sheet. I'm going to go ahead and multiply this out. The square of 14, I better check that out here on my calculator. 14 squared is 196. And 16 squared is 256. Okay, so I have this. And now what I'm going to do is I'm going to go ahead and isolate the square. I'll subtract 196 from both sides. I'll get x squared is equal to, this turns out to be 60. And unlike the other side where I did a theoretical problem on the other side and I left it in radical form like this right here, here I might be interested in not only the exact radical form of my answer when I take the square root here. So I'll get x is equal to, theoretically, plus or minus the square root of 60. But by the way, too, we won't have a minus version of this because we're looking for an actual distance here. So we know we really only have this. But because it's a practical distance, I might sometimes, like let's say I was trying to find out how tall a building was or how high the truck bed was if we put a 16-foot ramp here and it was a 14-foot distance here. You know, what would this height be? Well, that kind of thing, we might want to convert this then for practical purposes to a decimal. And so we would get our calculator and actually take the square root. Now where we round would depend on the problem, but I would get here second square root of 60 turns out to be I could round that off to maybe, let's say, 7.75 or 7 and that would be 7 3/4. But I could write down here that this is approximately 7.75 if I was rounding off to the nearest second place, right to the nearest hundredth. And you know, I think I'm going to try to turn this light a little bit. It looked like the light has washed out the writing a couple of times here on me. Okay, so we did that. Let's try one more application. So here's another application. This is a financial formula where you could go ahead and put an interest rate in, a certain amount of time, and an original investment, and come up with how much money you would have after those conditions were met. Yeah, but in this case, we know the before and the after. We're taking a $500 investment and we're growing it to $590. And we want to know what the annual interest rate would have to be for that to happen if that occurred in a 2-year period. So A is the amount of money at the end of the problem. P is the initial principal that we put into the investment. We don't know the rate of interest, but we do know this is 2 years. So we're going to solve this much like we did those problems that were above, because this does turn out to be a square problem, right? So if I first isolate the square, I'm going to divide both sides by 500. And that will give me a decimal on the left-hand side thereof, 590 divided by 500. And that turns out to be 1.18. And this turns out to be 1, so we're good. And we just have this, 1 plus r, the quantity squared. But because it's a square problem, we'll take the square root of both sides. And because it's a money problem, we're going to realize we'll get a plus minus again, but there's only one of them we want to keep. So what I get now is 1 plus r is equal to the square root of 1.18, plus minus really, for right now. We'll decide which one we'll throw out here in a minute. So now what I'm going to do is I'm going to go ahead and bring this 1 over. Let me go ahead and calculate this in my calculator though before I do that. And let's see what the square root of 1.18 is. The second square root 1.18, and that turns out to be about 1.086. So I'll have this. Okay, and then just because of the sake, just because of the room I have here, for the sake of space, I'm going to subtract 1. But remember, I don't want that to be part of the plus minus, so I'll put that in front. It'll be minus 1 over here if I subtract 1 from both sides. So look, we have two options. Only one of them makes any practical sense for an interest rate. If I do negative 1 minus 1.086, I'll end up with negative 2.086. Won't make any sense. So the only one I think I'll keep is the negative 1 plus 1.086, because negative 1 plus 1.086 is equal to 0.086, which is an 8.6% rate of growth or interest, and that's what would grow money from $500 to $590 in 2 years.